In the previous video, we looked at constructing a k-nearest neighbours classifier. In this video, we'll see how to use k-nearest neighbours algorithm to build a regressor. So let's begin. First, we create a new Python file named nnregression.py and then import these necessary packages. Let's generate some sample Gaussian distributed data. Next, we go on to add some noise into the data to introduce some randomness into it. The goal of adding noise is to see whether our algorithm can get past it and still function in a robust way. Then we visualize it with this code, i.e. we plot the data. We just generated some data and evaluated a continuous valued function at all these points. Let's define a denser grid of points. We defined this denser grid because we want to evaluate our regressor on all these points and look at how well it approximates our function. Now let's define the number of nearest neighbours that we want to consider. After this, we initialize and train the k-nearest neighbours regressor using the parameters that we defined earlier. Let's see now how the regressor performs by overlapping the input and output data on top of each other. Now we move on to run this code and see the output. You can see here the figure of input data, whereas the second figure depicts the predicted values by the regressor. So these dots represent the input data, while the dashes represent the predicted values. The goal of a regressor is to predict continuous valued outputs. We don't have a fixed number of output categories in this case. We have just a set of real valued output values. And we want our regressor to predict the output values for unknown data points. In this case, we use a sinc function to demonstrate the k-nearest neighbours regressor. This is also referred to as the cardinal sign function. A sinc function is defined as sinc of x equals sin of x divided by x when x is not 0, and it is equal to 1 when x is 0. When x is 0, sin of x by x takes the indeterminate form of 0 divided by 0. Hence, we have to compute the limit of this function as x tends to 0. We used a set of values for training, and we defined a denser grid for testing. As we can see in this figure, the output curve is close to the training outputs. In this video, we used the k-nearest neighbours algorithm to build a regressor for the data provided by us. In the next video, we'll build a similarity metric by computing the Euclidean distance score.